Aloha Indoor Air 2024. Today, I discuss a case study of the mitigation implemented for an installation of spray polyurethane foam, SPF, with high chemical emission rates. Following some installations of SPF, occupants experience odors and irritation many months after application. For sure, not all SPF installations result in persistent odor and irritation. I had SPF installed to the roof deck of my home attic without any problems, but sometimes there is persistent odor and irritation. In this case study, a two-part closed-cell SPF was mixed on site and applied to exterior walls and roof deck of a residence. The A components consisted of isocyanates, the B components polyol resin, fire retardant, and other additives. A chemical-like odor and irritation persisted after installation. We measured SPF chemical emissions and indoor air concentrations before and after removal with dry ice blasting followed by ventilation. Here is the event timeline. The installation of the SPF occurred over a 2-day period. On day 13, following complaints of odor and irritation, selected SPF hotspots were removed by the contractor. On day 37, we conducted air and bulk emission rate testing. After 400 days of negotiations between the owner, the SPF applicator, and manufacturer as how to best mitigate, all SPF was removed by scraping and dry ice blasting. On day 541, 14 days of ventilation with windows and open and fans were conducted, followed by 18 days without fans and operable windows. And then on day 574, the second test was conducted of the air and bulk emission rates. Here is a photo of the indoor space with partial removal of the SPF and prior to the scraping and dry ice blasting. At this point, about 22% of the SPF was removed. This is a photo after the complete removal by dry ice blasting. It estimated that it took about 6 days of dry ice blasting at a cost of approximately $5,000 a day. The chemical emissions of SPF bulk samples and wood samples with SPF removed were measured in a microchamber according to ASTM D7706. The indoor air concentrations were measured following US EPA compendium method TO17. The chemical emission rates from the two SPF samples were dominated by 3 VOCs, representing 74% to 81% of the total emissions. I should note that the manufacturer's safety data sheet listed 8 chemicals in the B component, 4 of which were unidentified. None of the 4 identified chemicals were observed in the SPF emission rates. The 3 dominant VOCs were 4-methylmorpholine, representing 42% and 52% of the SPF emissions. And this is believed to be an undisclosed chemical or a reaction product. The next most prevalent emission was from triethyl phosphate, representing 16 to 18% of the SPF emissions. This is believed to be the undisclosed fire retardant in the safety data sheet. And finally, the N,N-diethyl cyclohexylamine represented 13 to 14% of the SPF emissions, and this is believed to be the undisclosed catalyst in the manufacturer's safety data sheet. This slide shows on the left side the chemical emission rates from 2 SPF samples 37 days after installation. On the right side are the chemical emission rates from the 2 cleaned wood samples, followed by 14 days with and 18 days without openable windows and fan ventilation. The cleaned wood sample emissions were reduced by more than 96% to less than the detection limit of 5.3 micrograms per meter squared hour. For these 3 chemicals, which do not have an OHIHA CREL or an OSHA PEL exposure guideline, we used 0.5% of the DOE PAC 1 exposure guideline as determined from a comparison of chemicals that have both CREL and PAC 1 exposure guidelines. On the left side of this slide are the indoor concentrations with partial removal 37 days after installation. And the dimethylcyclohexylamine, the hazard quotient, which is how much it exceeded the exposure guideline, ranged from 3.7 to 17.1. For 4-methylmorpholine, the hazard quotient was 5.4 to 7. And for triethylphosphate, the hazard quotient ranged from 0.46 to 2.1. 500 on the right side of the slide, and 574 days after installation and with complete SPF removal, followed by 14 days with and 18 days without openable windows and fan ventilation. The indoor concentrations were all below recommended exposure guidelines. SPF chemical emission rate life. Based upon the measured SPF emission rates and mass concentration in the manufacturer's safety data sheet, the SPF emissions are expected to persist for many years, with a half-life, the time for emissions and indoor concentrations to be reduced by 1/2, ranging from 12 years for N,N-dimethylcyclohexylamine to 29 years for triethylphosphate. A period of 49 years is required to reduce chemical emission rates by 94% in the indoor concentrations below recommended exposure guidelines. Conclusions. With partial removal of SPF concentration, 37 days after installation, indoor concentrations exceeded recommended exposure guidelines with hazard quotients ranging from 0.46 to 17.1. With the complete removal of SPF by scraping and dry ice blasting, 540 days after installation, followed by 14 days with and 18 days without openable windows and fan ventilation, the chemical emissions from the clean wood substrates were reduced by 96%. The indoor concentrations were also substantially reduced by 89% to 99% and were less than the recommended exposure guidelines. It's important to note that most of the reduction in the SPF emissions in indoor concentrations were the result of the SPF removal and ventilation. The 400-day delay for negotiations regarding mitigation is expected to have resulted in very little reduction, just 3 to 6%. Further research is needed to identify the cause of elevated SPF chemical emission rates and effective mitigation strategy, either by removal and or isolation. Studies in a controlled laboratory setting to determine how much ventilation is required following the SPF removal to reduce the emissions of SPF insulation chemicals that have been absorbed into the clean substrate to acceptable levels. In previous studies, following the complete removal of SPF from wood substrates in a 24 hours of ventilation in a microscale stainless steel test chamber, significant chemical emissions persisted. In this case, complete SPF removal was followed by 14 days with and 18 days without openable windows and fan ventilation. And SPF chemical emissions were from the cleaned wood substrates were reduced by 96% to below the detection limit of 5 micrograms per meter squared hour. So the research question remains here is, if we do pursue removal, how much ventilation is needed following the bulk removal of all visible SPF? Thank you. Mahalo. I look forward to answering all questions that you either post here live or you post on the Indoor Air 2024 visual event platform. Thank you.